back in the application, let's actually create a new dummy service to highlight what's going on. I'll name this logging.service.ts file, that's the file name, and I added next to the app module, though that doesn't really matter. There, let me export the logging service, and first of all, let's provide it by adding @injectable with that object passed to it, where we set provided into root. Now, as you learned, this will provide the same instance of the service to the entire application. Here, I'll add a last log property, which is a string, and initially it's undefined. And then I'll add a print log method here, where I get a message, which is a string. And first of all, I simply console log that message, but I also set this last log equal to the message. And prior to setting this equal, I do log the last log, so the old last log, therefore. So we outlook the message and what was previously in the log, and then we overwrite what's previously in the log with the new message. Of course, this is really just a demo, not important to this application, but important for understanding the different service instance things. Now let's call this an app component in ng-on-init. There, let's simply inject the logging service, which is of type logging service. Make sure to add the import path here. And in ng-on-init, we can now call this logging service print log hello from app component ng-on-init. Now let's also add it in our shopping list component. There, in the shopping list component, we also have ng-on-init. So let's inject the logging service here as well. Again, make sure to add the right import path. And then ng-on-init, here let's simply set this logging service called print log, and there I print hello from shopping list component ng-on-init. Okay, so I got two places where I used that service. Now let's switch to the console in the DevTools and actually log out and reload the app. Okay, so now we see hello from app component ng-on-init, and then we see undefined. Undefined is simply stemming from that last log, which I'm printing here. Now let's navigate to shopping list. You see hello from shopping list ng-on-init, and you see hello from app component ng-on-init, because this is now our last log, which was stored, right? We do store it here. So we're printing this the second time print log is called. This kind of proves that we're using one and the same instance in the entire application, because we're using the service in two different components, and yet we're using the same object. Otherwise, last log would be undefined here as well. It isn't, and therefore we have proof that it's the same object as before. Let's change this by not using @injectable with provided in root here, but let's instead provide that service in the app module. There we can add providers, and we provide the logging service. Let me switch back to authenticate and reload. Same output as before. Let's go to shopping list. Same output as before. Because providing in the app module has the same effect as using @injectable. Let's get rid of that as well. Let's now use an eagerly loaded module, the core module. That is eagerly loaded because we imported here into the app module. There, well, I already do provide services here, so I kind of think that proves the point. But let's now add the logging service here, add the import as well, save that, go to authenticate and reload, same output as before, go to shopping list, same output as before. Now let's change that. Let's remove logging service from the core module, and let's instead provide it here in the app module as before. But let's now also provide it in the shopping list module. There, I'll add providers, and I'll provide the logging service as well. So now I'm providing it in a lazy loaded module, the shopping list module, and in an eagerly loaded module, my app module. Let's go to authenticate and reload. Same output as before. Let's go to shopping list. Oh, now the output is different, because we're now using two different objects, two different instances of that same service. We're using a separate instance in our application in general for the service provided in app module, But since the shopping list module brings its own instance by providing the logging service again here, the shopping list module and all the components in there use a separate instance of that logging service. They don't use the application-wide available instance, they use their own instance created by that child injector. Now, if you need that behavior, definitely use it. Nothing wrong with that. This is not a bug, this is an intended feature. But in general, you should think twice before you provide a service in any other module than the app module, because often it's not the wanted behavior, and you then suddenly have strange bugs when you're using different instances in your application. So if you need that behavior, use it, but generally be aware that there are differences in the instances you get when you provide services in lazy loaded modules. This also includes modules that you import into lazy loaded modules. For example, if I comment this out in the shopping list module and I comment this out in the app module, let's provide the service in the shared module. The shared module here in the shared folder, the shared module, of course, is also able to add providers. And let's provide the logging service here now. Now the shared module is imported by the app module, and therefore it is an eagerly loaded module, but it's also imported into the shopping list module. Now the shared module to the shopping list module is also eagerly loaded, but the shopping list module itself is lazy loaded, turning this here in this place, the shared module in this place, also into a lazy loaded module. So here the shared module is both. It's lazy loaded in the shopping list or through the shopping list module, and it's eagerly loaded into the app module. And the effect is that if we reload here, that works, and we see the output here on the app component, but we have the same issue, in quotation mark as before, because the shopping list module still uses its own instance because it imports the shared module into it. And that is the most problematic bug you often end up with when providing services in other modules. You might be providing a service in something like a shared module where you think, yeah, I'm going to put all my shared services into this. But you might still have shared services that should use the same instance across your entire application. Well, as soon as you're importing your shared module into a lazy loaded module, the services provided in the shared module will be recreated for the lazy loaded module. And all of a sudden, you might have a behavior you don't want. So whilst providing a service directly in the lazy loaded module might be something you control deliberately, providing it in a shared module is a common gotcha where you think you use the same service instance in the entire app when you don't. I know this can be difficult to wrap your head around, but this is a crucial thing and a common source of bugs. And therefore, the rule of thumb is that you provide services through @injectable or in the app module. If you do it differently, you should have a strong reason, and you should either be able to rule out that this module you're adding the service in is loaded lazily, or you deliberately want multiple instances. So we learned so much about Angular throughout this course. And by the way, there still are some bonus modules to come after this module here, so definitely continue thereafter. But at this point of time, I now want to show you how you can take your application as you built it locally and deploy it onto a server so that your application does not just run on your machine, which is nice for development, but not that useful for your potential users, but that you instead really ship it onto a server that it has its own domain and people can visit it from anywhere in the web. Now for that, we'll first of all dive into the necessary preparations, and then I'll show you how you can host your Angular application in the web. So how should you prepare your Angular application for deployment? There are a couple of steps through which you should walk and through which I'll walk you now. And the first is that you should use and check environment variables. That's something we haven't done thus far, and I will show you what I mean with that point and how you can use environment variables, what that is, and why you might want to use that. Well, of course, you should also polish and test your code. And that is what we did throughout this course already. For example, in the optimizations and modules course section, I already showed you some important polishments or, well, code optimizations like lazy loading. So it's of course things like that which you should implement, and obviously you should test your application, run it, try out different things, try working with it as your users would work with it. Once you're done with all of that, you can build your application for production. And that means that you run a command that takes all your TypeScript code, compiles it to JavaScript, then bundles all your code together, translates it into Angular language, so to say, so that the Angular renderer can work with it in the browser, and bundle everything up and optimize it to be as small as possible. Because the application you're shipping has to be downloaded by every user using your website, and therefore it should be as small as possible so that your users have to download as little as possible. And you do all that with the ng-build --prod command. You already saw that in the optimizations module, because you also need to run this to implement ahead of time compilation, and that's just one of the many optimizations the Angular CLI does for you behind the scenes. Now, once you're done with that, once you build your app, you can deploy these build artifacts, these generated files, to a static host. And now, what is a static host? A static host is a web server that is capable of serving HTML, JavaScript, and CSS, but that's not capable of running any server-side language like PHP or Node.js. Why? Because you only need HTML, JavaScript, and CSS, because an Angular app is made up of just that. Of course, you can have some backend code. For example, we are using Firebase in this course. This could be your own backend, which you wrote with your own language, and you should definitely check out my Mean course regarding that, because there I do show you how to build your own backend with Node.js as well. But if you're just working with Angular, if you're just building a single page application and you're not working on the backend on your own, then you in the end have just HTML, JavaScript, and CSS, and all you need for that is a web server that is capable of serving these files. So now let's walk through these steps together, most importantly the build and the deployment steps, of course, and let's see how that works.